Okay, 31 is another one that's got a nice complicated graph in the book, so I'm going to try to zoom in on it and then try to answer the questions. It says, add the y values when x is 2. When x is 2, the f value, y value is 2. The g y value is 1. So 2 plus 1 is 3. So f plus g at 2 is 3. B says, add the y values when x is 4. That's 1 and negative 3 is negative 2. C says, subtract f from g at 6. F at 6 is 0. G is 1, so 0 minus 1 is negative 1. Subtract g from f at 6, so that would be 1 minus 0, or 0 minus 1. Let's see, f, 0 minus 1 is negative 1 for C, and this would be 1 minus 0, which is 1 for D. Multiply f and g, the y values for f and g, at x equal 2. That'd be 1 times 2, or 2. Divide the f and g at 4. So f at 4 is 1. G at 4 is negative 3. So this would be 1 over negative 3, or negative 1/3. That's 31. Now 33 is about this free throw shots, and they give you this equation, and they say the velocity is 28 feet per second, and this will give you the height in feet for somebody who shoots the ball at the free throw line at about a height of 6 feet, around their head height. And so it asks you a bunch of questions here. So I have, for 33, we're doing 33, I put that equation into the calculator. I've actually put 2 of them in here, so I got to turn the second one off. So I put the cursor on the equal sign, press enter, and now it's off. And now I have the equation in here for the basketball. Negative 44 x squared over 28 squared, that's the velocity squared, plus x plus 6. And it says, use a table and find out how far the ball's, the height of the ball after it's traveled 8 feet. So I'm going to go second table set, and I'm going to start my table at 0 and go every foot. And if I leave it on auto and go to the table, it will tell me at 0 feet at 6 foot high, and then it goes up and up and up and up, and at 8 feet it's 10.40. And you can just do this without the table by just plugging 8 into the equation for x and solve it. But that's at 8 feet. That's A. Can you see all of that, I hope? Yeah. Okay. Now let's do it for the next thing they ask for is height the ball after it's traveled 12 feet. So I'll just go down a little bit further, and then at 12 feet it's at 9.9184. And you can just plug 12 into the equation for x's and get that. And find additional points. And so I've got all these points, and I could draw a graph of it. Or I could just say, go to the window and say it's going to go from 0 feet from the foul line to the basket is at 15, so I'll go 20 feet, and marking every 5 feet. And it'll start at ground. I'll have ground level and up to, let's say, 15 feet high in case somebody throws it that high. Now I graph it, and that's what the ball's path would look like. Nice parabola that we would expect. And this is just a plot of all the deals at 5 feet here, 10 feet, 15 feet, and 20 feet. The center of the hoop is 10 feet above the floor at 15 feet. So if we trace and go out to 15 feet, or go back to the table at 15 feet, we see that its height is down to 8 feet, And if the basket is at 10 feet, this is an air ball. The ball is passing below the basket at that distance. Okay? It says, if not, with what initial velocity must the ball be shot in order to go through the hoop? Well, it must be shot with a little higher velocity, so we could go back to our equation and try playing with that. And that was the 28. So let's make it 29. And then second table. Now at 15 feet, it's just a little bit low. So second, so back to the equation. Let's make it 30 feet per second. Graph. Oop. I can do the graph. You notice it's higher here. And I could trace and see what it is. Let's trace and get out to 15 feet. 12, 13, 14, 15 feet. It's at 9.9, not quite enough. So go to the equation, go to 31. And this time I'll use the table because it's easier to get to 15. It's at 10 points, 10 and a half feet. So somewhere between 30 and 31 should go through. Okay, maybe 30.5 would put it right at the height to go in the basket. But it needs to clear the basket rim, so 10 and a half feet is not too bad. That might bounce off the back of the rim, so somewhere around there. And that is 33. 33, and then 36 is the weight formula, and that's the other one I have in here. So I'll turn this one off by pressing enter on the equal sign, turn this one on by pressing enter on the equal sign, and I've put in the equation for a 120-pound person and the height. And so now I can look at it. Let's see, we're going to look at how much would she weigh at on Pikes Peak. So now I'm going to do a little different thing on the table set. So I'm going to go to table set, and I'm going to go to ask. So now if I go to table, it gives me nothing, but it allows me to put something in. So if they're at Pikes Peak, which is 14110, but I'm supposed to put it in miles, so I have to divide by, there's 5,280 feet in a mile. This would be miles, and if I put that in there, it says it's 2.6 miles, and this person would weigh, let's put it over here, at Pikes Peak, the person would weigh 119.84. Not much lighter, but a little bit lighter. Using the graphing utility with m equal 20 to graph it. So now we're going to want to get it in miles. So the window, I can go from 0 to 20 miles high. That's reasonable. And the weight will start at 120 and go down. So I'll make the bottom, it's not going to go probably below 100. And I'll start it, go to the max of 120. And now if we graph, we should see the weight going down. There's 120 and here's 100. Didn't go down much even at 20 miles high. Okay. Now do a table that starts at, it says start it at 0, going by steps of a half a mile. And so now you got to put it back on auto. And how much does the weight vary as age changes from 0 to 5 miles? Second table, at 0 it's 120. At 5 miles it is 119.7, so it varies 0.33 pounds at 5 miles high. A third of a pound roughly, 3/10 of a pound less. Not much. At what height will weigh 1995? 119.95. So we'll go back here. about 1 mile high. And does your answer seem reasonable? Yeah, 1 mile is about 5,000 foot. So if you go up into one of the peaks around here, get up to about 5,000 feet, you're going to be 1/2 of 1/10 of a pound less, 1/20th a pound less. And those are the questions from this section.